All right, welcome everybody to another live stream. My name is Brian McLogan, and we are going to cover the ellipse in our Chapter 4 Analytic Geometry. So if you have looked at my channel here, you can see that I just went live here a little bit earlier. I had a little technical difficulties yesterday when I was trying to do my live stream on the parabola. So I did that earlier today, but now this is kind of a little bit more of my schedule. I'm a little bit later. I had to take, a little 45 minutes to kind of eat my dinner and everything else. So I'm going to try to do a live stream though, but since it is a little bit later and a little bit off center, I'll try to kind of pick this up. And also I want to see if I can get into any questions that some of you guys may have, as I know we're kind of getting into that time frame of the school year where, you guys are going to start having exams and everything else coming up. So if there are some questions you guys have, I'd also like to be able to see if I can maybe answer some questions, or at least maybe direct you guys in the right direction as you guys start preparing for them. We should be finished up in my class with instruction here in probably before April. And so therefore, hopefully I'll be able to help you guys with some of your, tests and do some live streams just for you guys, to prepare for your own classes as far as exams getting on there. So, because obviously this whole year we've mostly been dealing with the pre-calculus, but that's obviously the whole purpose of what we've been doing here. But I always like answering questions. So I'll try to see if I can get through this this stuff here rather quickly so I can answer maybe some questions you guys have. So if you do have some questions, make sure you guys just go ahead and answer. Go ahead and add in your next into your next question. Or, sorry, if you do have some questions, make sure you guys add them into the chat, and then I'll try to adjust them. But what I'm going to do is I'm just going to kind of cover these first 6 problems here on the front, and then what I'll do is take a quick little break, see if there's any questions or anything I can address from you guys. And then after that, we'll go ahead and head into the multiple choice questions. Again, guys, this is a homework assignment that I gave to my students while covering to help them understand the information that we learned for the ellipse. I also asked them to do all this stuff, but I didn't ask them to graph. So I am going to add that in there, at least for myself, as far as graphing, because I think the graphing portion is just helpful when understanding what you are doing. All right, so without further ado, let's go ahead and get started. I see all of you guys in here, and I will check in. That's great to see you guys. Good to see everybody joining in for a nice little live stream. I'm actually bigger. No, I'll just keep it like that. I just need to remember. I think that the update here on the eCam, the software, has made my face a little bit bigger, on my screen a little bit bigger. So I just got to now be aware that where my pencil is writing, that I'm not going to be able to see what I am writing up there. So, all right. Anyways, let's get into this. So we got 954. Cool. All right. So the first example here, we need to identify our H and our K. So this is our H, this is our K. So what I'm going to do is I'm going to kind of identify, our parts here. So we have our vertex, H and K. We see that, remember, for an ellipse, a squared is always larger than b squared. So I can say a squared is equal to 25. B squared is equal to 16. Remember, to be able to figure out c squared, we're just going to do a squared minus b squared equals c squared. So therefore 25 minus 16 is going to equal 9. So therefore c squared is equal to 9. Okay, perfect. Now actually you didn't need to you did need to figure out that for your foci. The next thing I need to know is where my major axis is. It horizontal or is it vertical? We can see that the a squared is under the x term, so therefore we know that my major axis is going to be horizontal. That's important because the vertices lie at the end of your major axis, as well as your foci lie at the end of your major axis. So, and I guess I added in minor vertices and eccentricity. All right, so let's just go ahead and plot this, so therefore we can describe everything. So we have our center, not vertex, center at 2, 2. So all right, center at 2, 2. All right. Now again, we're going to have a horizontal major axis, and therefore my vertices are going to be a distance of 5 units away from that. So it's going to be 5 units to the right. So 1, 2, 3, 4, 5. And then 5 units to the left, which would be 1, 2, 3 here. Okay. Now you can just, obviously the nice thing about using a graph is you can just kind of like count here. Or you could take this vertice, the center, and then subtract 5 and then add 5. So therefore you can see that the vertices, the major vertices, is going to be at -3, 2, as well as at 7, 2. So therefore what I'm doing is just adding and subtracting 5 to my vertices. Now the nice thing again about knowing this major axis is horizontal is that we know also my foci lie left and right from here. So my foci is just going to be adding and subtracting the square root of 9, which would be 3. So therefore that's going to be -1, 2. And then adding 3 to that would be 5, 2. So therefore we have foci, and then 1, 2, 3, 4, foci. Okay. Now the minor vertices, also known as the covertices, is a distance of b units away, which is 4. So now remember, those are not on the major axis; those are on the minor axis. So that is perpendicular to the major axis. So 1, 2, 3, 4, and 1, 2, 3, 4. Okay, so therefore I'm going to call these the covertices instead of the minor vertices, just to reduce. I kind of went through a lot of different ways that we can have these described. Now that's going to have the same x-coordinate of 2, but now that's going to be up 4 and down 4. So that would be 2, 6, and then 2, -2. All right, and then the eccentricity. All right, so the eccentricity is basically telling us kind of like the shape of the ellipse. Is the ellipse more going to be like a circle where the eccentricity would be 0, or it's going to be really kind of spread out where it's actually approaching to 1? So again, for the eccentricity, all we're going to do is take E equals C over A. So in this one, we're going to have C, which is 3, over A, which is 5. So that's going to be a 3/5. So there's all the information, and then obviously if you wanted to or you needed to go ahead and sketch it, you can just connect your covertices with your vertices and you'd get something like that. And remember, that's your center. We'll call that the covertices from there. Okay. All right, so let's go ahead and do another one here. You can see here, kind of similar in the same regard. We don't have any coordinates with the x, or we don't have an h in this case. So we could say h is going to be equal to 0, or we could say the center is going to be 0, -1. Remember, it's the opposite form here. Let's see here. We got a squared is going to be the larger of the two denominators, which in this case is 5. B squared is then going to be 4. And c squared, remember, a squared minus b squared, so I can do that in my head. That's going to equal 1. Let's do a in this case. So a is going to be the square root of 5, b is going to equal 2, and c is equal to 1. Now, the reason why I don't do plus or minus, like when you square root, is because when we're looking in for these value, or the definition of a, b, and c is the distance, not the distance and the direction. Because if you notice, the vertices are going to go in the positive as well as the negative direction. The foci go in the positive as well as the negative direction. The covertices go in the positive as well as the negative direction. So we're just looking for that distance that they are apart, or that they are away from the center. So there's our center. Let's go ahead and graph this over here. So we have 0, -1. Now we notice that the a squared is under the y. That means now we're going to have a vertical major axis. Sometimes what I do is I actually draw a dashed line that's going to represent my major axis. So if I'm like kind of having a hard time just like remembering or getting this, sometimes I'll just draw the major axis. So that reminds me that my vertices as well as my foci are going to be going up and down from that major axis. And then again, this is what I wanted to make sure I'm aware of. Okay, so my vertices are going to be square root of 5 away from this point. Now you might be kind of stuck and sorry, well, what is the square root of 5? Well, the square root of 4 is 2. And the square root of 9 is 3. So the square root of 5 is going to be somewhere in between 2 point something, right? So if I had -1 plus, let's just say 2 point something, I'm going to have, 1 and something left over. So that'd be up 2 and something, so it's going to be somewhere around there, and then I go down 2 and something right there. So there's my vertice, there's my vertice. If I was going to write that out, I would just simply write this as my vertices I just write this as 0, comma, -1, and then really just add plus or minus the square root of 5. Now, the rest of the numbers are whole numbers, so that's a little bit nicer. The foci here is going to be adding and subtracting 1. So therefore, here we're at -1, so therefore we have there's a foci, and then going down 1 is another foci. So in this case, we have 0, comma, -2, and then 0, comma, 0. And then the co-vertices, or the minor vertices, is going to be left and right, and that's going to be a distance of 2. So therefore, we're from 0, then the y-coordinate is going to be the same, but now it's going to be -2, -1, and +2, -1. And then last but not least, we got the eccentricity, which is just going to be c over a. So that's going to be 1 over the square root of 5. And again, just in case it is simplified, we know that we can rationalize the denominator here to square root of 5 over 5. All right, so that's when we have basically two equations in standard form. It's fairly kind of, the process is simple. It just takes a little bit of practice, and then you kind of get used to it. Sometimes you'll have fractions and radicals, which kind of messes things up. But as far as the process goes, it's a little bit, it's really the same thing. So now let's kind of look at some equations that are not in standard form, that are kind of maybe in your general form. Well, in this first example here, this is very close to standard form, but standard form we have it set equal to 0. So in this case, we do not have this equal to 0. To write this in standard form, we're going to need to make sure this is equal to 0. So what we're going to do is we're going to get rid of that 32 by dividing by a 32 on both sides. Remember, just like the distributive property, we got to divide that 32 into the numerator, into both of these expressions. So therefore, 8 over 32 reduces to 1/4. Plus 4 over 32 reduces to 1/8, and then that's equal to 1. All right, so now in this case, you can see that my, my a squared is going to equal 8, right, because a squared is always larger than b squared. My b squared is going to be equal to 4, and my c squared is going to be a squared minus b squared, which is also equal to 4. My a is going to equal to the square root of 8, which is equal to the square root of 8, which we do not want to reduce to 2.8284271, but yet we want to simplify that as 2 radical 2, and then b would be 2, and c would equal to 2. Okay, so now let's go ahead. We notice that there is no h and k here, so my center, that wasn't supposed to happen. So my center in this case is going to be at 0, 0. We also notice that the a squared is under the x, so therefore we're going to have a major axis that is horizontal. So let's go ahead and graph this. Okay, so we're going to go left and right for our major axis. I'll just say MA is the x coordinate is going to be my major axis. Let's go ahead and find the vertices is basically going to be plus or minus 2 square root of 2, and that's going to be going left or right. So my vertices, I'm just going to go plus or minus 2 square root of 2, comma 0. Again, now I can estimate that as 2.8284271. So therefore, that's going to be like there. Actually, you know what? Let's make those nice and bigger. All right, so we'll just estimate that to that, and that to that, and we'll say vertice, that's your center. The foci here is just going to be 2 units to the left and 2 units to the right, because again, remember, the foci have to lie on the major axis as well. So that's your foci. So that's going to be, I'll just write plus or minus 2, comma 0. So there's a foci, and there's a foci. And then the last one is our co-vertices, which is going to be b distance away from the center, but that's going to be not on the major axis. That's going to be on the minor axis. So that is going to also be up or down too. Okay, and then guys, we can just go ahead and connect if you wanted the shape of everything. Okay, nice and beautiful. I forgot to write in what the co-vertices were though. Co-vertices, and and that's going to be from 0, but that's going to be up and down too. So that'd be 0. Oops. That's going to be 0, comma, plus or minus 2. And then the eccentricity is just going to be C over A, which is going to be 2 divided by 2 square root of 2. The 2's divide out, and you can rationalize the denominator to give you square root of 2 over 2. So a little bit of manipulation we can do there. All right, so now on to the best problem of the homework, the completing the square problem, the one that the students are, struggle with the most because it's just so much more work on this problem compared to all the rest of these, right? So the main thing we want to do is this is in general form, and what we're going to want to do to understand this, you guys, hopefully you kind of get this process down pat now. To understand the rest of this, all we simply need to do now is just convert this into standard form by completing this square, by creating these binomials squared. So the first thing we're going to do here is, I'll skirt that up like that. First thing we're going to do is we're going to group the x's and the y's. So I'm going to put the 4x squared minus 8x plus y squared plus 4y, and I'm just going to put the 8 to the other side. All right, now I'm going to group the x's and I'm going to group the y's. Now what I'm going to do is, since I need to have a binomial squared for the x's and for the y's, I'm going to complete the square. Now before you can complete the square with the y's, with the x's though, you need to make sure you factor out that 4. So that's a very, very important step. So make sure you go through that before before you complete the square, because when we're completing the square, we want to make sure our quadratic terms have a coefficient of 1. And then I'm going to go through this color coordination because I think this is really helpful for you guys to see it, even though it can be annoying for those of you that know what's going on and are waiting for me to keep on changing my pen color. I apologize for that. But I think it really is helpful to visualize on this process. So again, guys, remember to complete the square, to create a perfect square trinomial, we're just going to simply do b divided by 2 and square it. Now we need to do this for both quadratics here. We need to do it for this quadratic, which would be negative 2 divided by 2, which is 1, negative 1, squared, which is just equal to 1. And then we need to do it over here. 4 divided by 2, which is 2, squared equals 4. Now we're going to take these values and we're going to plug them into our binomials. That is creating our perfect square trinomial. Don't forget about that 4. So now we have x squared minus 2x, and then we're going to add the 1. And then we're going to have a plus y squared plus 4y, and then we're going to add the 4. Close the parentheses, equals 8. Okay? Now, we got to be careful here because we just don't want to say, okay, we're done. Because think about just what we did. We just added some terms here on the left-hand side. Well, this is an equation. We can't just add terms on the left side and then not add them on the right side. So I added a 1 here on the left side. That means I have to add that 1 back on the right side. But be careful. Because of the distributive property, you didn't really add a 1. You added a 1 that was multiplied by a 4. So I need to multiply that 1 by a 4. Then we added a 4 on the left side. It's not multiplied by anything. So therefore I need to re-add that 4 over there on the right side. Okay, so now what we can do is we can rewrite these terms. Now we can take our perfect square trinomials and factor them back down. So therefore, this is going to be 4 times x minus 1 squared plus y plus 2 squared equals 8 plus 4 is going to be 16. Now, just like the last problem, we don't want it to be equal to 16. We want it to be equal to 1. So I'm going to divide by a 16 on both sides. Again, make sure you distribute that 16 into both of them. And then I arrive at my final equation without answering one question, which is x minus 1 squared, 4 over 16 reduces to 1/4, plus y plus 2 squared over 16 equals 1. Now, all of that work I have done, and I still have not answered one question. So let's try to kind of do this. I'm sorry, I'm going to do this a little bit more in my head. Let's go ahead and graph this though. So I'm not going to write down as much. This is 1 comma negative 2. There's my center. Notice my, actually I can write down some things. A squared is 16. B squared is 4. And C squared is going to be the square root of 12, which is also equal to 2 times the square root of 3, which is approximately between 3 and 4, so 3 point something. But I'm not going to worry about the sketch. I'm just going to answer the information because I'm kind of a little low here. All right, so we have the center. That's given your h and your k, so that's going to be 1 comma negative 2. We know that since my a squared is under my y here, we're going to have a major axis that is vertical. So that's going to be a is going to be up and down from there, from your vertices. And remember, a is going to be 4. So if a squared is 16, that means a is 4. So basically, I'm just going to take to find my vertices, I'm just going to add and subtract 4 here. So to 4 to negative 2. So if I subtract it, it'd be 1 minus negative 6. And then if I add it, which I don't think I have any more room, that would be 1 comma add 4, which would be comma 2. Let's go ahead and do the foci, which is also going to be along the same axis there. That's going to be a distance of c, which is 2 square root of 3. So therefore, that's going to be the same x-coordinate, but the y-coordinate is going to be negative 2 plus or minus 2 radical 3. So in that one, I'll just write plus or minus because I can't really simplify it from there. And then let's do the co-vertices. Co-vertices are going to be going left and right from the center. That's going to be a distance of 2 because b squared is 4, so that means b is 2. So therefore, I'm going to be adding and subtracting 2 from 1. So my co-vertices is going to be negative 1, negative 2. And then if I add 2 to that, it'd be a 3 comma negative 2. And then my eccentricity is just my c over my a, which again, a is 4. So therefore, this is 2 radical 3 over 4, which simplifies to square root of 3 over 2. Whew, very, very in-depth problem, but hopefully I didn't make any more mistakes on that. I didn't make any mistakes here for you guys, and hopefully it all made some sense. And I did cover up some of my work, which I knew I was going to do because I'm testing out this new update. All right, so last two, then I'll take a quick little break here, and then we'll get on to the multiple choice. So the next one, next two questions is basically for writing the equation of an ellipse. And when you're writing the equation of an ellipse, I think the main important thing is to plot the information. If you don't plot the information, then I'm going to get very upset because I think plotting the information gives away what exactly you need. You need a couple things. You need to understand what is the orientation of the ellipse. Does it have a major axis, horizontal or vertical? That tells you which type of equation you're going to use. Where is a squared under the x or the y? You need to understand what the vertex is, and you need to understand a and b. If you figure out those three pieces of information, you're going to be able to write the equation. So first thing we do is my major vertices, which again are my endpoints of my major axis. So that's 1, 2, 3, 4, and 1, 2, 3, 4. That's very cool and important because now I know my major axis is going to be horizontal. I know that the center is the midpoint of my two vertices, which is at 0, 0. And I know that the distance from my center to my vertice is a, which is equal to 4. Now, I have the distance for my foci is at 3, 0 and negative 3, 0, which again confirms that my center is my midpoint. It also gives me the value of c, which is 3. And that's very important because if I know c and I know a, I can figure out the value of b. So again, just remember a squared minus b squared equals c squared. So a squared is 16 minus b squared equals, wait a minute, what happened? That's 3. Minus b squared is 9. All right, so I'll go ahead and subtract a 16. Negative b squared equals negative 7, and therefore b squared is equal to 7. Now, I don't need to solve for b. I just need to figure out what b squared is, right? So, again, we notice that the major axis is horizontal. That means my a squared is under my x. I don't have any h and a k, so therefore I'm simply just going to have a x squared over a squared, which we know is 16, plus y squared over b squared, which is 7, is equal to 1. And there you go. All right, next one, we have the minor vertices. So again, this is perpendicular to the major axis. So if this axis is vertical, then I know my major axis is horizontal, right? So anyways, let's plot the points. So we have 2, 3, 1, 2, 3, and 2, -1. Okay, so again, we notice that the minor vertices or covertices are vertical, so therefore, yeah, my major axis is going to be horizontal. We can also figure out the midpoint here, which is going to be where the center is, which is at 2, 1. So I can say the center is at 2, 1. I'm just going to write that down so I don't forget it. I know that B is going to equal 2. And since the major axis length is 8, that means I know so therefore I can say 2A. Ugh. What's going on here? 2A is equal to 8, therefore A is equal to 4. So now, therefore, if A is equal to 4, then, and I know what B is not equal to 8. What am I doing? What happened there? B is equal to 2. All right, but you can tell that, again, this is a major axis that is horizontal. So then, again, my a squared is going to be under that x squared. I need to subtract that from these coordinates. So this is going to be x minus 2 squared all over a squared, which is 16, plus this would be y minus 1 squared all over b squared, which is 4, equals 1. There you go. All right, let's go ahead and take a quick little break for you guys, and then what I'll do is I will get into some of these multiple choice. This is the second live stream, so I apologize for yawning. I'm a little tired. It's a long day, and I still got a lot of stuff I got to do after this live stream, so I don't want to go too much longer. But I do check in, see Zach, Louie. I'm not in your class, but you helped me on my homework. That's very good, Louie. Happy to be able to help you out with that. And 37 Productions Logarithm. Hamza, happy to be able to help you out. NVOM, I wonder how can you ever memorize these all faster? I get better, but I never really memorize any of this stuff, so I'm improving over time. Yeah, it really just comes with practice. I mean, look at what I do. I mean, I do this every single day over and over and over again, and that's what I tell my students. Like, mathematics is obviously like your brain is like any other muscle. The more you're going to be doing the problems over and over, the repetition is going to make those connections in your brain. And so, I mean, that's what I tell my students, when you're preparing for a test, like just doing a lot of people look like, oh, your homework's like so easy and blah, blah, blah. Well, yeah, for some students, the homework is easy. For some students, the homework is hard, right? Like everybody's different. Not this homework isn't, meant to match everybody's level. It's just there to give you hey, here's a baseline of some problems that you should know how to do. However, for many students, this homework is not sufficient to prepare them for their test and quizzes, not by any means. So we do problems in class. I do offer, additional problems, and that's why textbooks, they have so many extra problems. That's kind of nice for students that you can just practice. I remember when I was a student learning, I would practice a lot of extra math problems that were never assigned, that I was never going to get credit for, but I would do them because I knew that I needed that practice to really understand the material. And that's when I started to do better in mathematics, is when I would practice. Well, thank you, Zach. I very much appreciate for your kind words. You did not have to cheat every 10 seconds. Yeah. He said, do. Jeremiah. All right. Well, guys, I am going to, cool. I'm going to go ahead and get into the multiple choice, and then we'll kind of wrap this up. If you guys do have some questions, I will go ahead and check into some different things, see if you guys have any, see if I go and check in, see if you guys have any questions I can answer for you. All right. Okay. An ellipse with the major axis from -7 to 3 to 5, 3, minor axis from -1 to 2 to 1, -1, 8. We're trying to write the equation of the ellipse. So let's go ahead and plot that information. So I like the major axis because I know that's going to be my a squared. So that's going to be -7. 1, 2, 3, 4, 5, 6, 7, and that's 3. 1, 2, 3. And then I have 5. 1, 2, 3, 4, 5, 3. Okay, so we know that the center here is, it looks like that's going to be at -1, 3. So I can automatically see that my x coordinate needs to be at x equals +1, y equals -3. My a in that case would be equal to 6. So a squared is equal to 36. The only one that even matches that, obviously you have there, but the only one that matches the correct center here is going to be a. Everything else is not correct by any means. So as far as finding where the center would be. So the center obviously is the midpoint of your two vertices. And you could also, if you did the midpoint of your two co-vertices, you'd get the exact same, which is going to be obviously at -1. You can see that x coordinate. So that's good enough from there. For the next one too, I need to again set this equal to 1. So I'm going to divide by 40 on both sides. So I have a x squared over 5 plus a y squared over 8 equals 1. All right, they're all 0, 0. Good. My a squared is equal to 8. So the square root of 8 is 2 radical 2. So that's my a. Since that is under my y, that means my vertices are going to go up and down. So it can't be this one because that's changing the x coordinates. Obviously, it's not going to be 8. It's the square root of 8. So it's not these two. So therefore, my chance is B, which makes sense. Your origin, your center is at 0, 0, and you're going up 2 square root of 2 and down 2 square root of 2 to find your two vertices. And then obviously you could do the math to find the difference between A and B, which would be 3. So that would be the square root of 3, which is also going to be up and down. So B is confirmed. The next one is trying to identify the circle. So we got to complete the square here to identify the center as well as the radius. So let's go ahead and group the x's together. X squared plus 8x plus y squared minus 4y equals -11. Group these two terms, group those two terms. 8 divided by 2 is 16, so x squared plus 8x plus 16. Make sure that I add 16 over to the right side. Sorry. And then I have plus y squared minus 4y. -4 divided by 2 squared is going to be a +4. So then make sure I add a 4 over here. So now I'm getting x plus 4 squared plus y minus 2 squared equals 9. Okay, so you can see the radius is 3, so not A and not B. And you can see the center would be opposite of H, opposite of K, so that's going to be a -4, 2. So my answer is C. Question number 4 says, write the equation for the circle. Center is at 20, center R, 24, 5 passing through. So let's go ahead and graph this. So we have the center of 24 and 5. So let's just put it over there. It's going to be in the first quadrant, right? And then the other point is at 24, 0. Well, again, guys, if it has a point here and it goes through the center, then that has to be the radius. That's the nice thing about a circle is, if you have the center and you have a point on the circle, that distance from the center to that point is going to be the radius, which in this case is 5. So obviously, if the radius is 5, the equation is going to give us 25, where the only equation that would make sense here would be this one. I just want to make sure that gives us the correct center, which it does. So A is going to be our answer. So there you go, ladies and gentlemen. That is the homework for the ellipse. I'm hoping that helped. I'm going to try to answer some questions. I only got about 5 minutes left. As I mentioned, guys, I got quite a bit of work that I got to come through. But just wanted to say some hellos to Zarif and Toxic and Noah Boy and Bill Natzarup. When's your next Q&A? I will do a Q&A. I'd like to be able to do one. I'll let you know, Bill. It's going to be on my channel. I will try to do one a couple days in advance. I got a lot of things. We had to finish up the quarter, before spring break. We had spring break, and now we're trying to finish up. And then I'm creating all this content. So I will be planning on doing a couple Q&As. I will be planning on doing a review session for my pre-calculus class, going through the study guide. And then for all of you guys that are also taking pre-calculus or, want to review. So I'll be doing a lot of that stuff for you. So definitely get into that. All right. Dragon, make more videos like this. Well, thank you, Dragon. Hopefully that I can do it. Every spot, do you remember me? No, I'm not sure I remember what exactly you are referring to. So maybe let me know, drop me a comment, and I can see if it was a comment or on a live stream. I'm not really sure if I remember. All right, so we got something into standard form, please. Okay, well, we did that into standard form. Well, yeah, we did that for a written equation. All right, good luck on your test, Talia. No, boy, your channel died. Well, thank you very much. Appreciate that. Noah boy, hi. Best teacher but dying channel. Well, that's sad to hear. Okay. All right. Well, let's see. Any other questions? Well, you're very welcome, Tom. I'm very happy to help. I had 2 questions wrong. I couldn't work it out. Hi, Brian. I recently had an exam and I had 2 questions wrong. I couldn't work out where I went wrong. Could you do a video on how to work out the answer, even using different values? I'm not really sure, Tom, as far as... you know what? I'm not going to have time for this. I only have a couple minutes left. But if you had an example of whatever else, I can, also try to see if I can figure it out for you to help you out. There we go. Every spot. The channel is alive. Very good. Very good. So, well, guys, I'm doing pre-calc in college, and trigonometry requires a lot of understanding and memorizing. Yeah, I mean, as far as it goes down to the point of, as far as like memorizing, my whole thought process is there doesn't really make much sense to like memorizing a lot, for this class. Obviously, when it comes into a test, you're going to need to know a lot of the stuff, right? You're going to need to have quick access to it in your brain. But spending a lot of time, trying to memorize things just for that test is not going to do you much good. I think it's a lot of time that's, you're not going to remember a lot of that stuff, and you're just doing it for that one time. However, I really do believe working through extra problems not only helps ingrain that into your brain, but it also helps you understand the problems a little bit better. And then especially what happens in mathematics, which I know many of you are aware of, you get to a problem, you think you know what you're doing, and then your, professor, your teacher gives you something that's a little bit different, something you haven't seen before, and then you kind of get stuck. Well, by really having a lot of that foundation of have tried a lot of problems, a lot of different types of problems, you're going to be more prepared to be able to adjust and working on problems like that. Where if you simply just try to memorize everything, then you're not going to have that practice of working through problems that are a little bit different and being able to adjust. So just a quick little piece of advice for you guys. Hopefully that helps some of you guys out as you are starting to prepare here for some tests and upcoming exams. But otherwise, guys, I think does make sense to do a lot of the Q&A and another open Q&A, or at least try to continue that for the week and get some questions here from you guys. So I will I'll try to schedule a Q&A maybe for next week that we can do that, where you guys can submit some questions to me ahead of time, and we can spend some time doing that. Because we will have time to do that next week, because I will be through with my videos. So let's plan on that. Next week I'll do a open Q&A. So thank you for reminding me on that, guys. We'll do an open Q&A next week, probably like Thursday, because I think they'll be taking their quiz on a Wednesday. So we'll probably do the live stream on Wednesday. So for my students, and then I'll do a Q&A for you guys. So all right, guys, cheers. I got work I gotta do and school tomorrow. Adios. Bye-bye.